Let us discuss another problem on ladder friction. The problem runs like this. A ladder of length 6 meters is placed as shown in the figure, taking the coefficient of friction between ladder and floor as 0.4 and coefficient of friction between ladder and wall as 0.25. Weight of the ladder is given as 200 Newton. Actually, weight acts at the center of gravity of the ladder. The ladder supports a weight of 900 Newton as shown in the figure. Determine the least value of theta. The theta is the angle of inclination of the ladder, so that it won't slip. So it can be avoided without slipping, or so that the ladder is in equilibrium. Now here there is no other forces. So here only this weight, this load is acting, 9 Newton is acting at a distance of 1 meter from the top end of the ladder. And the weight of the ladder is acts at the center of gravity of the ladder, which is at a distance of 3 meters from here, because the length is 6 meters, total is 6 meters. So the theta is unknown here. So similar to the last problem which I had explained, you can have 3 right angle triangles here, like this. This is theta, which is not known. So this is BA. So this length is 6 meters. Length of the ladder is 6 meters. So this becomes 6 cos theta. This becomes 6 sin theta. Please note that here theta is unknown. The second right angle triangle is this CA. So this length is from A, it is 6 minus 1, that is 5 meters. So here also this is theta, which is not known, 5 cos theta, 5 sin theta. Then the third triangle is the smaller one. It is G here, A here. This is theta. This is 3 meters. 3 cos theta, 3 sin theta. So these are the distances, because we need the distances to compute the moments. Now here also you can see that if you write the free body diagram of the ladder, so it will be something like this. So AB is the ladder. Now I am writing the free body diagram, FBD of ladder. By replacing the contact points by the respective reactions, here you can see that since the tendency of the ladder is to slip down, the direction of motion of ladder will be downwards like this, so that the frictional force acts in the opposite direction, that is FW, and normal reaction will be like this, NW. Similarly, the ladder tries to move towards left here, direction of motion of ladder, tendency to move towards left, therefore frictional force acts towards right, FF and NF. And you also know that the relationship between FF and NF is mu F into NF. Of course, here mu F value is given as 0.4, so 0.4 NF. And here also FW is nothing but mu W into NW. So mu W he has given coefficient of friction value between ladder and wall as 0.25, so 0.25 NW. Now if you replace, if you write those forces here, so it is like this. This force will be here, 900 Newton, acting at C. And center of gravity G is here, weight of the ladder will be acting here, 200 Newton. Distances, this is 3 meters. This is 1 meter from here, so all these are known. Now I will replace these contact points A and B by the respective reactions. So FF is acting towards right like this, so that FF can be written as 0.4 times NF. 0.4 times NF, and NF is like this. Both are acting at the point A. And at the point B you have FW and NW. FW will be acting upwards like this. 0.25 NW you can write. And NW will be like this. Both of them will be acting at B. So this is the free body diagram of the ladder. So total you have 6 forces here. NF, 0.4 NF, 200, 900, 0.25 NW and NW. Now of course, you know this consists of a coplanar non-concurrent force system. So three equilibrium equations you can use to analyze the problem. The first one is sigma fx0, forces acting towards right, positive and right. So 0.4 nf. So see the free body diagram and write the equation. 0.4 nf acting towards right. Then this nw is acting towards left. So minus nw will be equal to 0. So this is the first equation you are going to get. Second equilibrium equation, sigma fy is equal to 0. Upward forces positive, downward forces negative. So here upward, so nf is positive. Then here 0.25 nw is also positive, so plus 0.25 nw. But these two are negative because they are acting downwards. Minus 200 minus 900 is equal to 0. So in other words, nf plus 0.25 nw is equal to 1100. So this is equation 2. You cannot solve because there are two unknowns. Now you can find out nf and nw by solving these two simultaneous equations. So solving 1 and 2. Solving 1 and 2, nf and nw can be found out. Now let us see how to solve these two equations. We can solve using the calculator also. So the first equation is 0.4 nf minus nw is equal to 0, or I can write this as nw is equal to 0.4 nf. Now substitute this nw is equal to 0.4 nf in the second equation. Substituting for nw in equation 2, so you can eliminate that nw. So nf is as it is plus 0.25 into nw can be written as 0.4 times nf, that is equal to 1100. So therefore, if you solve for nf from this, so nf into 1 plus, this is 0.25 into 0.4, so which comes out to be 0.25 into 0.4 is 0.1 is equal to 1100, or nf can be written as 1100 divided by 1.1. So 1100 divided by 1.1 is 1000. So you are going to get nf as 1000 newtons. 1000, because the weight of ladder and the load on the ladder is given in newtons, your frictional forces, normal reactions also will be in newtons. Once you get this nf, therefore nw, you know, it is 0.4 times nf. So 0.4 times 1000, which is 400 newtons. Now I will use the third equation to equilibrium equation to find the value of theta. The third equilibrium equation is the moment equation. I will take the algebraic sum of all the moments of all the forces about the point A and equate it to 0. I will consider clockwise moments positive, anti-clockwise moments negative. Now if I use that concept, now I am here, so I have to take the distances now. Now let us take one by one. So the first I will take this these two forces. Now I have to consider the moments of all the forces about the point A. Of course, these two forces, they don't have moment about A because they are passing through A. Your lever arm value will be 0. Only I have to consider these three. Now I will consider this. This is, of course, I have written like this. Doesn't matter whether I take the ladder like this or like this. Anyway, the angle theta remains same with respect to horizontal. Only thing is I get the horizontal distances and vertical distances from the point A. Now you can see here at the point C you have a 900 Newton load. So here this is 900 Newton, and at the point D you have 200 Newton load, weight of the ladder. Then at the point B you have two forces. One is that NW, another one is that FW. So that is NW FW, those two are there at B. That means I have to take like this, NW, and another FW will be like this, that is 0.2 times 2 times NW. Now by seeing to these diagrams, we will write sigma MA equation. So first I will take this 200 Newton, this is a clockwise movement about A, and the distance is horizontal distance, which is nothing but 3 cos theta. So 200 into 3 cos theta, positive. So 200 into 3 cos theta. Okay, then coming to this 900 Newton, this is also giving clockwise moment. 900 into, I have to take this 5 cos theta. So plus 900 into 5 cos theta, because 900 is vertical force, distance will be horizontal. Then coming to this diagram, this NW is giving an anti-clockwise moment about A. So minus NW into distance of NW from A, which is vertical distance, 6 sin theta. 6 sin theta. Next, 0.25 NW is giving a clockwise moment about A, and the distance is 6 cos theta. So plus 0.25 times NW into 6 cos theta. So that means I have considered the moment of this, moment of this, moment of this, and moment of this. These two doesn't have any moment about the point A because they are passing through A. This will be equal to 0. Now substitute for NW. So NW value is here 400. So substitute the value of NW as 400. So this is 400 and this is also 400. And if you simplify, so this becomes 600 cos theta plus this is 900 into, what is it? 900 into the distance is 5. So this 5 cos theta. 900 into 5. 900 into 5 is 4500 cos theta. Then 400 into 6, that is minus 2400 sin theta. Then this is 0.25 into 400 is 100. 100 into 6 is 600. So plus 600 cos theta is equal to 0. You get a trigonometric equation in terms of sin theta and cos theta. Let us see what is the equation we are going to get there. The only thing is we have to find the value of theta there. That's all. So here, if you simplify that, 600 plus 600, 1200. 1200 plus 4500 is 5700. 5700 cos theta minus 2400 sin theta is equal to 0, or you can write this as 57 cos theta is equal to 24 sin theta, or sin theta by cos theta is equal to 57 by 24, that is tan theta is equal to 657 by 24, which is 2.375. Therefore theta is equal to tan inverse of 2.375, which is 67.2 degrees. So the value of theta you are going to get is 67.2 degrees. So this is how we have to solve the problem. By taking the third equation, you will get a trigonometric equation in terms of sin theta and cos theta that can be converted to tan theta. So theta can be followed. These are all the values under limiting friction. That means at the time of impending motion of the ladder, so these are the corresponding values. So you should be very careful in writing the moment equation. So 200 into 3 cos theta, once again I will check, 200 into 3 cos theta, that is here, like this. Then plus 900 into 5 cos theta, that is also correct. Minus NW into This is 6 sin theta plus, sorry, that is not plus, actually this is also minus. That's what. So both are minus there. So both of them are giving anti-clockwise. So that is minus. Minus means it becomes minus 600. Yeah, minus 600 cos theta. So this gets cancels. So you should be careful. That's what. So now value of theta is different here. You should be very careful when you are taking moment equation. So it becomes 4500 cos theta is equal to 2400 sin theta. Okay. So otherwise we can write it as sin theta by cos theta is equal to 45 by 24. That is tan theta is equal to 45 by 24. So 45 divided by 24 is equal to 1.875. So therefore theta is equal to tan inverse of that. So tan inverse of 1.875 is 1.875. Tan inverse of 1.875, 61.9 degrees. 61.9 degrees you are going to get. So that is the value of theta, that is the angle of inclination of the ladder. So this is what this is how we have to solve the problem. Anyway, in the problem of a ladder friction, so many parameters will be there, as I already told. Among them, 3 only you can find out. Any of them can be given as unknown. So maybe horizontal force that will be applied at the bottom of the ladder, and an angular inclination of the ladder, or mu values they can ask, mu f or mu w, any one of them they can ask. So like that they can give any unknown, they can ask any unknown, but the procedure is same. You have to write the 3 equilibrium equations. While writing the moment equation, you should be careful. You need to have the horizontal distances and vertical distances and the corresponding moments that you are going to get, whether it is clockwise or anti-clockwise, treating clockwise positive, anti-clockwise negative. You have to write down the equation and then you have to solve the 3 equations to get 3 unknowns. Among those 3 unknowns, always 2 unknowns will be NF and NW. Please note, always NF and NW, they are the 2 unknowns. In addition to that, one more unknown will be there. That one more unknown will be either it can be horizontal force that will be applied at the bottom of the ladder, P, or it can be inclination of the ladder, theta. So any one of all, it can be mu f or mu w. So these are the unknowns. Any one of the unknowns can be asked. Of course, this NW and NF, those two are 2 fixed unknowns. Along with that, any one of these can be asked. So this is how we have to solve a problem of ladder friction.